Today I'm going to talk about how I made my first ever automatic base designer in screeps. I just want to add a caveat. It's not that great, but it does work, and hopefully it's a bit of inspiration for people who are struggling to work out how to get started with automatic base build. So the first thing is, I'm just going to assume you have some kind of familiarity with screeps, and more specifically, some familiarity with the different structures. You don't need to know all the ins and outs or anything like that, but just, a casual awareness of what's in the game, basically. So what we're going to go through today is how I designed what are called stamps. I'll tell you what those are, and then how I placed them on the map, because my method is a stamp-based method. We'll talk about that in a minute. I'm also going to talk briefly about how you place your first spawn, or how I place my first spawn, sorry, because obviously your code doesn't start running until you've placed your first spawn, so that is an issue you need to overcome. How I built my walls and my ramparts, and how I placed the towers, which I often call turrets. So if I say turrets, just assume towers. I apologize. It just sounds better for them anyway. And as I go along, I'll be talking about some of the things that don't quite work and how maybe in the future, when I come back to this, I'll improve it along the way. So, first of all, I want to note that not all of the ideas I present here are my own. I have taken a lot of help and a lot of inspiration from the Screeps Discord, and anyone who is looking to get started with this game, I would strongly recommend joining. It's a great bunch of people, very helpful, and a lot of very experienced players there. The next thing, as I've already very briefly mentioned, is I don't claim everything I did is the best way. It's just a way I've done it, and it's good enough, basically, for a start. Which I think is quite important, because if you want to get going in this game, you can spend forever making it perfect, but there's so many things you need to do, you might as well do things to a reasonable standard and then come back and iteratively improve. The final thing is I will not provide any code. And my reason for this is it's a programming game, and I don't think it's very fair that people can just copy and paste someone else's code and be like a top player in the game. So yes, I'll provide ideas, but not code. Great. So first of all, what are stamps? Stamps are a predefined configuration of structures that are used to build a base. And you can, for example, build your entire base as one stamp, like the picture here on the left, but doing so will limit which rooms you can build in, because you have to be able to fit the whole base in as one stamp, so some of the more sort of wall-heavy, maze-like rooms simply won't work for you and you won't be able to set up in there. Or you can have parts of bases, like this one here, when you have multiple stamps to build the whole base. That's how I do it. And there's also a third option called dynamic allocation, which is you sort of grow the base based on the terrain around you, which I don't do, and I obviously didn't even provide an example for it, but we'll talk about that briefly as we go on. So, what do we need to build? So, your first stop with a lot of this stuff is the Screeps documentation. If we look here, we can see at the different levels of our room controller, we have different number of structures we can build, and we basically want to build all of those. Now, for your bot, you should really call the constants instead of hard coding in the different values. So for example, the relevant one here is controller structures. And the reason for this is if there's ever any updates, you can make sure that your base builder still works appropriately. Okay, so moving on, these are the different stamps that I use. Again, I didn't design all of these myself. Some of them are taking inspiration from other people. Briefly, what we have on the left column is a series of extension stamps. So what I try and do is I try and place 10 extensions. If I can't, I try and place 5, and then if I can't place 5, I'll try and place 1s, essentially. On the right-hand side here, I have like a central base stamp. So this has like your nuker, your storage, a spawn, a power spawn, a terminal, and a link, and then a rampart in the middle for where basically a base operator will sit to move things around between those buildings. Underneath that, I have the lab stamp. This is a pretty standard configuration. When you design your lab stamp, you want to make sure you have 2 source labs, and then all the other labs are within 2 range of those. This is the current meta. And I've also added a container, and the reason for the container is when you unboost creeps, the resources will just drop on the ground otherwise, so the container is just there to collect those. And then finally, you get a structure called an observer, and you can build 2 more spawns, so I put those in that last stamp there. So Placing your first spawn is a bit challenging because, as I mentioned, your code doesn't run before you place the first spawn, and I use an external Python script basically to do that. Very briefly, you can use the API to get the terrain data, and then you can use that to work out where to place it. That is here, sorry. Yeah, you can see there's different endpoints that you can use to pull different information or push different information, and this is very useful as a tool to know about, basically. So, step one of the base builder is cleaning the room that you've just set up in, and the reason for this is if there's like random walls or roads left over from whoever was there in the past, those can actually get in the way of where you want to place your stamps, so it's a good idea just to delete everything when you get in there and start. I place containers next to the sources, mineral, and controller, and I put a rampart on the container. And the reason for this is I'm using static miners, and static miners, as the name suggests, don't move around, and they'll just drop the resources on the floor otherwise. And if they do that, then they'll start to decay. And I put ramparts on the containers so that if someone comes into attack, they can't very easily access the containers. And I label the ramparts not to be used for turret placement, but we'll talk about that later. Cool. Step 2. We need to work out where we're going to put the stamps. And to do this, I do what's called a distance transform. And I do this from the controller. So this is our controller over here on the left. Bearing in mind, always remember, diagonal distances in screeps are also 1, just like horizontal and vertical distances. The walls, we don't let the distance transform go through because we can't build on a wall. So, for example, if we look on the right here, you can see that the distance 67 occurs because this wraps all the way around the bottom and back up again. The large number on the walls is just a default value, don't worry about that. So that's how we're then going to work out where the stamp should go, because we want to try and build as close to the controller as possible, because my argument is it's easier to defend if you build your base around it. So we're going to place the stamps in order. So we're going to place that central stamp I mentioned with the nuka, the storage, that kind of thing. Then I'm going to place the labs, then I'm going to place the 2 other spawns, and then finally I'm going to work on the extensions. And the extensions are, if you can't place 10, place 2 5s. If you can't place a 5, place 5 1s. And stamps must also be a certain distance from the edge of the room. And this is important for when I come to do the walls a bit later. So I think I define that as it must be a minimum distance of 6 from the wall, just to make sure that we can definitely build the wall path, which I'll talk about in a minute. Great, so this is what the end result looks like. So this is an actual base that I designed, that I'm currently living in, hopefully for much longer. The white dots are the different structures, the red dots are roads, the yellow dots are containers. So, you saw all those stamps. They're not actually connected together with roads. They're all split up, and that's not great. We want to glue them all together. So what we're going to do is we're going to build roads between all the different stamps, and we're going to label them as inner roads, which is important for walls later. I will remind you of this. Don't worry, you don't have to remember all of this. And then we also connect sources and minerals and the controller via a road as well, but we don't label those as inner, and that'll become more clear in a minute. So this is what it looks like after I've put the roads in. As you can see, all the stamps are nice and connected to each other, and although our base is a little bit spread out, it's at least it's connected and it works. Ideally, in the future, what I want to do is dynamically grow where the position of the extensions are specifically, such that we don't end up in this situation where the base is split up. But a quicker fix might be to actually just get rid of the 10 extension stamps and only use like 5 extension stamps, because those could be more easily sort of tessellated through this sort of awkward environment that I've deliberately picked for a test. Now we're going to build the walls. The goal is we want to place as few ramparts as possible, and we want to basically shrink wrap our base, and that's what we're going to try and do. So this is an example of what the end result will look like, or the path that we're going to build. So what we do is we basically build a path that circles the base as close to the base as we can, while also placing the minimum amount of walls, or ramparts, sorry. So how do we do that? Well, first of all, remember, because we labeled roads as inner roads, our base actually forms a single blob. So if you imagine here, in this picture, you can see that all of these roads are all inner roads here, and this base will basically form a blob. It's a weird shape, but you can't, for example, move through the base to the other side without crossing any of the base buildings. So this is an example of what that might look like. You can see we have a base here on this grid, blue like roads and buildings, that kind of thing. So now that we have our blob, what we're going to do is look on the left-hand side and draw a line across, which I've labeled with green squares and the letter L. And now what we're going to do is do a weighted distance transform, which I'll talk in a bit more detail about in a minute, from below the line, wrapping around the base. When we do this distance transform, we cannot cross the line, so we can't go back and just make this distance 2. We can't cross the base area here, and we also can't move within 2 tiles of a building, or 1 tile from a map edge if it's an exit, because you can't place a wall there. We do a weighted distance transform starting from below the line. So plains and swamp have a weight of 20, and terrain walls have a weight of 1, which basically means it costs a lot more to go through the plains than it does through the walls. The distance transform cannot cross the impassable points that we mentioned before. So this is what this looks like. So zooming into where the line is on the left-hand side, the line is given as zeros. -1s are the places we can't cross, so we have a inner road here, 2 distance from that. And the reason we have this 2 distance rule is if there was, for example, a rampart here, a creep with ranged attack could sit there and shoot the road, and we don't want it to be able to shoot base buildings, so this is why we put that in. So yes, we have our zeros. This is a plane, so it's 20 distance. This is a wall, so it's 1 distance. And this is what the whole room looks like on the right-hand side. So as you can see, we start off with low numbers, and we wrap around all the way to the other side of the line, and these are the numbers we end up with that touch that. So now we have done this distance transform, so now what we're going to do is build this path that we described before. So what we do is we take 1 step above the line, shown here, and we find the lowest value first. So in this case, this will be 459. So this is where we will start. Now, on the first step, we can't go backwards because that's the line. We're not going to move left and we're not going to move right because we're already at the lowest value. So the only place we can go is up. Bearing in mind, when you build walls, you can't build them diagonally. So all the steps we take have to be either horizontal or vertical. And the reason for that is creeps can actually move through the diagonal line, and this is why we can't use the in-game pathfinder for this. So this is why we'd be building this distance transform. The only other rule is if we find an identical number, so if we find, let's say, a 50 and then there's another 50, we move to the identical number if that identical number takes us closer to the start position. But generally what we're going to do is always take a step to the lowest number we can. So for example, we go 459, 458, 457, and then it will be 456 here, etc., etc. And also, if we hit 0, we move, but we're not back at the correct place. Let's say we end up here. We move up 1, and then we move across to the start position. The reason those 2 rules are in place are testing and just finding some pretty weird edge conditions. Cool, so we have our path. Now we need to add either walls or ramparts to this path. Cool, so how are we going to do that? The first thing we're going to do is what's called a flood fill. So what a flood fill does is you take an area, and if you can imagine, if you pour water into that area, it will fill the area it can, but if it's blocked off in certain places, it won't fill on other sides. I'll show an example. It's a lot easier to understand. If a position on the path touches the flood fill, we can place a rampart, otherwise we place a wall. If we place a rampart, you cannot place a wall until you hit a terrain wall, and again, this is just because of some edge conditions from testing. It's nothing like high level or anything like that. Cool, so this is an example here. So what I've done is the flood fill always starts from the controller here, and we filled this area. The flood fill is blocked by terrain walls and also by our path. So where we see here, this flood fill is next to our line. In these places, we'd place a rampart, but in this location here, we would actually place a wall. So why do we have locations where we'll place a wall? Well, it's because this square here would have been, for example, -1, and the only way it could carry on going is to go up by 1. And the reason why this could be -1 is it's actually within 1 or 2 distance from a structure. So this is why we build a wall. The reason I'm placing a wall, not a rampart, is we're not going to defend it, but it's there just to make it just that little bit harder for them to come and destroy structures that we actually want to protect. Cool. So we place our ramparts now, and this is what they look like. The green squares around the edges with the red dots are the ramparts. And the reason why they have the red dots is we're also placing a road inside the rampart to make it easier for our defenders to move. Okay, next what we want to do is add some access roads. So in case someone's attacking our base, I want my defenders to be able to get to the ramparts as fast as possible. So what I'm going to do is take my path and split it into segments, where each segment is started by a rampart and ended by a terrain wall. So if you can imagine here, this would be one segment, that would be another segment, that would be another, etc., etc. Cool. And we basically want to draw a road, to each of the rampart segments. So we calculate the path for each one, connecting it to the base, and then for the first 2 steps, we add another rampart. And the reason for doing this is, as the defenders are going to the rampart, we don't want them to be able to be shot by enemy attackers. And this could basically help us with a bit of creep design as well, because then we don't need to worry about putting too many toughness parts on, because they're not going to ever be shot unless the ramparts fall, sort of thing. So yeah, it's quite a useful little trick. Great. So it's time to place the towers. So, okay, let's think about what we want to do when we're placing towers. First of all, we want to place them inside the base area. We don't want them to be able to be accessed by the enemy attackers, and if they're in the base area, they're easier for us to reload, that kind of thing. And we want to maximize the minimum damage outside the ramparts. So what I mean by this is, if we imagine our ramparts, if there's a certain location where the minimum damage, say it's really small, like a weak spot that the enemy can attack. So we want to make sure that the minimum damage along the outside of the ramparts is maximized. So what we're going to do is define a set of valid positions along the ramparts, because what we're going to assume is the best place to place the towers is just right behind the ramparts to try and maximize the damage. I don't have formal proof for this. This is an assumption we're making, and doing this particular algorithm, I do make these sort of assumptions, but you know, it's good enough. So this is what's called the maximum diversity problem now. So what we have is a set of positions, which is one distance from the rampart, and we want to place the towers, such that they are maximally distant from each other. And yes, you can look up the maximum diversity problem. There's all sorts of different solutions out there. Spoiler alert, I don't actually solve it properly, because instead we just make some assumptions. But first of all, I'll just show you the valid positions. So the red X's, shown on a zoomed in version here, and for the whole room here, are where we can potentially place a tower. So we have 6 towers to place in total. I'm assuming, and this is quite the assumption, that we will have 6 valid positions at least to put a tower. Cool. So we need to prune our positions. As I mentioned, we have 6 in total to place. So what we're going to do for the first position, we'll construct the distance matrix for all of the possible positions where we can put them. So it's all of these red X's as a reminder. And then what we're going to do is sum the rows of those distance matrix, and the largest sum is the first position we picked. And as an intuition as to what this is the most isolated point, is the idea. And we just say, right, it is an assumption, we just want to put a tower at that isolated position. Great. So for the remaining positions, we calculate the distance to all currently accepted positions, and then we find the minimum of those distances and the largest minimum win. So for example, if we have 2 positions that we've accepted already and we want to work out where the third one goes, if it has a distance of 5 to 1 and 1 to the other, its minimum distance is 1, and that's basically its score, and the highest score then wins. So whichever position is the largest minimum. So this isn't perfect. It does solve it. So here is an example of what this looks like. So we have 1 there, 2 over here, 1 down here, and then 2 there. And hopefully you can very easily see that if I just move this one across, it'll be slightly better. But again, in the spirit of this is good enough. This is good enough. So I'm happy enough with this such that I don't feel the need to change it or do it any better. And it's fast as well. Okay, so what about links? I haven't really talked about those, and honestly, I plan to add them in as part of my economy code later, so I'll have to work out which remotes I'm mining, that kind of thing, to try and work out an optimal position for them. So we're not going to talk about that now. And yeah, that's about it. That's the base plan. To be honest, the wall planning algorithm is something I'm most proud of. I am not aware of a better way of doing it. I know a lot of people use minimum cut. This is conceptually a lot simpler, and it runs in about 17 CPU on Shard 3, which is pretty nice. I just want to give you some final notes. You will need a custom cost matrix that you update as you place structures for when you're doing the paths and the roads. Make sure you keep that and maintain it properly. As I mentioned before, there's better ways of solving that maximum diversity problem. We assume that those edge positions are best for towers, but that's not been proven. And make sure you do tests in lots of rooms when you build your base builder. I have found through my own experience that there's always another edge case where your algorithm doesn't work properly or in some other way breaks. Thank you very much. I hope this has been at least a little bit informative. And if you have any suggestions or comments or anything like that, please let me know. I think I'm pretty much done with the base building stuff. I'm going to move on to other aspects of the game now, but hopefully we'll revisit it in the future, and I'll be sure to give you some updates when we do. Thank you very much for listening.